Hi everyone, my name is Vitalii. First of all, I also wanted to ask to give a round of applause for the organizers, Harlis, Christo, and others. It's an amazing conference and it's a pleasure to be here. So, better medicine. So, what I will really talk about is kind of behind the scenes. That's why you see the flag debug equals true. Behind the scenes of better medicine. So what actually goes into helping radiologists do cancer diagnostics more faster and accurately? More specifically, what we do, we analyze computer tomography images, analyze it with AI, and then send the AI results back to radiologists with the information where there might be potential tumors, like lesions, cysts, so they can do the cancer diagnostics accurately and more faster. Just a few words about me. I'm CTO and co-founder of Better Medicine. Previously worked in companies such as Wise, maybe you heard, such a small company, and Starship. I'm from Ukraine originally, but in Estonia I'm already living for 8+ years. Currently also learning Estonian, finally. Got to realize that I need to actually to know the language and that I actually like learning Estonian, surprisingly. In my free time, I do things like Brazilian Jiu-Jitsu, barefoot running, sometimes in snow, a little bit of geeky thing, training on gymnastic rings, playing games with my son Luca, Lego, and I was thinking, should I teach him Rust as the next thing? But maybe he's too young. Future accomplished tech writer. Currently only have 4 blog posts. Maybe in the future we'll have more. What else? I'm coming from the background of software engineer. In Wise and in Starship, I worked as software engineer. So I'm not a DevOps person per se. So I barely know how to exit Vim, all right? So, all right, and a little bit about our team. So we are a small startup. We've been, Better Medicine has been, let's say, alive officially for 2 years, but we managed to collect a really good team of different expertise. Piri Saloma previously, as you know, probably is the founder of Moon Cascade, has the entrepreneurship side. We have Martin Reim, who is president of Radiology Society. Bodja, Dima do AI. Helena is in the UK, helping with operations, and most importantly, I'm proud to have Thomas and Veljo in my team as product engineers. I really want to also give maybe 30 seconds of time to talk about Ukraine, because Bohdan, our chief of AI engineering, actually sits in Ukraine. He's in Lviv, and sometimes it happens that we have meetings, and he says, sorry, I need to go to the bomb shelter because they have siren alarms. So if you want, you can do official donations to Ukraine. Ukraine would appreciate that. I just thought, as Ukrainian, I feel, I would say, even an obligation to mention it right now. All Ukrainians are trying to bring the voices to the world about the situation that happens. And I appreciate a lot Estonian support. On a personal note, I want to say that when the war started, many of my Estonian friends wrote to me personally and asked if my friends need accommodation in Ukraine. And I appreciate it a lot, and I'll never forget about it. But now, coming back to the problem that we are solving. So the problem we are solving is the fact that the cancer is going up and the number of radiologists go down. So we really need to optimize how they work. We need to make their cancer diagnostics faster, at the same time not compromising their accuracy, but even making it better with the use of AI. So, and the real problem as well is that when they do cancer diagnostics on computer tomography images, they do a lot of repetitive tasks. So for example, when they find a tumor and they know it's a tumor, they have to measure it with manual tools, like put a cross on the tumor in their medical image viewers, and then they have to write manual report of what's the measurement of the tumor, etc. So there are many manual steps, and we can automate all of that, or many of those tasks. So what we do, we find, measure, and classify lesions with AI. Then we monitor progression over time and deliver structured reporting. And again, I'm here trying not to sell you anything about our product or something, but I'm just giving you a context of what we're solving, so to serve it as a background for technical problems that we are solving and why we are doing it. So this is, for example, how in our medical image viewer that we are building now, this is, for example, how the segmentation of AI looks in the viewer. So, for example, when the radiologist opens the computer tomography, he can see the segmentation of the tumor. Let's say if it's a kidney tumor, potential cyst, also the measurements, and let's say this is the kidney organ. And the good thing is that these measurements you see a 2D slice, but for you to understand, there are like many of these slices over the whole body. So this is pretty much 3D, in a way, 3D model of the body, a 3D scan. So, and once we have the segmentations from the AI, we can automate delivering the report, the final report of the radiologist with his findings, because we can, for example, measure the volume of the tumor and provide all of this to the radiologist. Another thing, or the challenge that we have to do, is we have to make it very easy for radiologists to work with AI. So they have to be able to edit the segmentations, to maybe change the class. Let's say if it's not a tumor, it's a cyst. So it should be easy for the radiologist to interact with the AI. And we take it very seriously. It's a very important challenge to solve. So now going more to the technical side and where we are right now. So in order to actually sell our AI or have this in the cancer diagnostics workflow, we have to regulate it. So that's what we are doing now. We are in the process of running clinical study in Tartu University Hospital. And one of the crucial steps is we have to move the data from the hospital to our cloud. Let's say for labeling and later for the experiment, etc. The crucial part is that in order to do that, you have to do it really securely. And you have to prove to the hospital, or at least ensure them, that this is secure and no sensitive patient data should end up on our cloud. It should be completely anonymized. At the same time, once we have the results of our experiments, let's say, it should be possible to match it back to the original patients in the hospital. So this process is called pseudonymization. This is when you send the anonymized part to your cloud, but once the AI results are there, let's say, and you need to match it back with the original patient, you reverse anonymize. So you match it with the original patient. And it turns out there are more details there than meets the eye. So what we've built the what we call Better Medicine Gateway, which does this anonymization. So pretty much what happens is that when there is a scan, it ends up in the PACS, which stands for Picture Archiving Communication System. Hopefully you don't have to learn this term in your life if you don't deal with medical imaging or medtech. But the PACS pretty much is the database for storing CTs. You can think of it that way. So what we do, we receive it in our gateway. The whole protocol for CT images is called DICOM. Again, not maybe that important for you to know, but just a word to remember, DICOM. So we have this DICOM, which has DICOM has three main components. It has bytes of the CT image itself, of this one slice, as you saw in the previously. It has tags and it has a bunch of tags, like key values for patient name, patient ID, study ID, date when the CT was made, etc. And some of them are sensitive, some of them are not sensitive. Some of them we can send to our cloud, some of them we cannot, like patient name, for example. So what we do the whitelisting, and then we do obfuscation, and then we do the upload. So what is the process of obfuscation? If, as I said, the DICOM file, which is this like one slice of the CT, as you saw in the medical image viewer, it has these three categories. Firstly, we can think of them as different IDs, like patient ID, study ID. Then there's personal data, and then there's some metadata, like image position, orientation, etc. So when we send stuff to the cloud, we definitely don't want to send the patient name and other information. But even the patient ID is too sensitive, because if our data somehow is leaked, on the cloud, and let's say hackers somehow leak the hospital system, they will be able to match those IDs. So we cannot afford that. At the same time, we cannot just randomize them or not send them, because for our AI, it's important to trace one patient over time. For example, if you want to provide the dynamics or the history of the patient. And for AI training, it's important to have this continuity of one ID. So we do the obfuscation. Obfuscation is not done with a simple hashing. It's done, I'll go into details exactly how we do obfuscation, but the idea is that given the same patient ID, and let's say some secret, we will have all the time the same deterministic obfuscated ID. So this process is called obfuscation. And then we can send it to our cloud eventually. For the cloud, we use Google Cloud, and we store them initially in the buckets, but later we kind of import them into, let's say, Google DICOM store or PACS, where it stores the CT data that we later use in our reviewer. So a little bit about this obfuscation. So, and where the interesting challenges become. So for the obfuscation, we use HMAC as SHA-256. It's not a simple hash in a sense that the problem with simple hashes, let's say if we were just to hash the patient ID and send it to the cloud, let's say you have patient ID 12345, you hash it with SHA-256, and you send it to the cloud. Well, the problem is that if our cloud is leaked, the hacker can just brute force our hashes and get back the original 12345. That's an obvious brute force attack, so we cannot allow that. So we have to do something smarter, and what we do is we hash with a secret, right? And the algorithm for good algorithm for that is HMAC SHA-256, where you take a secret, you take the body that you want to hash, and then you have in the end you have a secret hash in a sense. Now the problem is the secret. Because when we started to talk with hospitals, let's say we partner with several hospitals, they didn't want the secret to leave the perimeter of the hospital. So, okay, if the secret doesn't leave the perimeter of the hospital, then how do we manage the secrets? Well, we need some kind of key management system, right, or something. Well, it turns out the hospitals might not have key management system, or if they have, it's maybe used in very specific contexts and it's hard to integrate with them. So it's not the same as using nice Google Cloud KMS. So there was this challenge where, yeah, how do we manage secrets? Do we, offer hospitals to do the on-premise KMS, like HashiCorp Vault, and we will manage it ourselves? But you have to remember that we are a small team, and for us, this managing for each separate hospital, the KMS is, first of all, it has a room of error, because we have to organize it, the whole KMS setup ourselves. We're only 3 engineers, and we really want to build our core offering, which is help radiologists do cancer diagnostics. So we had to do something smarter. And what we ended up doing is what's called envelope encryption, right? So I managed to, and that was maybe the biggest challenge as well when talking to hospitals. I said to hospitals and to their, let's say, IT departments and the people who were stakeholders, let's say, I said, hey, look, the secret will never leave the hospital that is used for the obfuscation. But we will store it encrypted by another key, right? And this key, another key, will be coming from the Google Cloud KMS. So we generate the key once, the secret key, securely in the hospital, and then we encrypt it with another key. We pretty much use the encrypt operation for the Google Cloud KMS, and we store the key always encrypted on the hospital. And what it ensures is that if the data is leaked in the hospital, they will just get the encrypted key. And if the data leaks on our cloud, well, the key lives encrypted in the hospital. So it's like a kind of two-factor authentication, you can think of it, envelope encryption. Moreover, it works like this, right? You have some data, you have a data encryption key, you wrap it with key, you wrap this data encryption key. Well, first of all, you have a data encryption key, you encrypt your data, and then when you store the data encryption key itself, you first of all encrypt it with KMS. This way, on your storage system, the whole data is encrypted. And in our case, the storage system, think of it as a hospital. And the KMS lives in the Google Cloud. Now, important thing about KMS, as all of you might know, and the beauty of using Google Cloud KMS, first of all, it's well managed, and the key never leaves the perimeter of the hospital. And if, for example, when we might, let's say, assume that there might be some breach or some problems, we always can rotate the keys, plus we can rotate the keys on a regular basis, we can revoke them, etc. So this is, in a way, how we solved key management and encrypting or obfuscating data. And the decrypt operation is the other way around. You first decrypt the data encryption key, and then you decrypt the data itself, and then you can return it to application. So what do we use for this? It turned out I had a nice chat with one software engineer from Google Health. We just chatted over video, and he said, hey, look, I think you need to look into Tink for crypto operations. Tink is used in Google Cloud internally. I think, if I'm not mistaken, correct me if I'm wrong, but Tink uses this for also pretty much all their Google Cloud encryption. And internally, it's very well tested. It's open source. You can check it in GitHub, and it has pretty much implementations or bindings to most of the languages, including Go. And Go is the main language used for the backend. So Tink was actually a very good choice because Tink has very clear interface. And the most important is Tink allows you, what is the beauty of Tink? And what is let's say, there are many crypto libraries out there, right? What's the problem? The problem is when you misuse the API. And this is where the main challenge comes. Like, you can misuse the API. For example, if you, expose the key, but Tink makes it, their APIs are really crisp, and it's hard to misuse the library. And this is very important when you use the crypto, because the most mistakes come from the silly mistakes when you forget something or you misuse it. I've seen many people misusing JWT libraries, trust me, when they get the JWT on the server, the token, and they never verify the signature, they just parse the body. So pretty much the attack vector was you could put whatever you want into JWT, like you could say you're admin, and your library would just pretty much parse that you're admin and say, okay. And this was from the misuse of the library, because library allowed it to be misused and not check for the signature by default, let's say. So this is just one example. And Tink makes it very easy to do the envelope encryption. Plus, there are many adapters for many KMS. For example, for Google Cloud KMS, AWS KMS, HashiCorp Vault, or you can build your own adapter. And that's the beauty of that, or your own implementation. So I recommend to check it out if you deal with some crypto stuff or encryptions. And this, you don't have to look into detail, but this is pretty much all the details that come when we receive this one DICOM file. And we have to whitelist, or we have to securely anonymize it before sending it to our cloud. So first we whitelist it. It means we throw out the data like patient name. Then we obfuscate those IDs. For that, again, we decrypt the key. We obfuscate. And then to be able to do reverse anonymization, when finally AI results come back to the hospital, you have to match the obfuscated IDs with the original IDs. So we also encrypt the original IDs, and we generate the data encryption key for those, let's say for them, per each CT scan. So each CT scan has its own data encryption key. So that also, we could say it increases security, but yeah, we don't use like one global data encryption key. The only global data encryption key is for obfuscation, because that's necessary for the continuity of the hashes to be the same for the same ID. But for encrypting the other parts of data, we use the new DEC, or data encryption key, for new CT scan. And the envelope encryption is done by talking to cloud storage by using encrypt operation or decrypt operation. All right, then this is all about, like, say, anonymization. This was just to give you maybe open the door in the complexities or let's say important things. Let's say medical imaging startups should care about handling patients' data very carefully and very seriously. And it's indeed a very serious topic. And currently many hospitals struggle, and many health institutions, to move data around. Some still use like USB sticks around and do this or that, and it's all happening in the industry. And that's one part, let's say, of the puzzle we had to solve to securely transfer data to our cloud. All right, then a little bit about our infrastructure, other things. So we use Cloud Run, not Kubernetes yet. Again, we're a small company, pretty much excluding AI engineers. We're only 3 engineers, including me, Veljo, Thomas. And we decided that Cloud Run is fine for us. So for example, we use it for the backend for our medical image viewer. Again, Yagni, you ain't gonna need it until you really do. That's the principle from Kent Beck, right, in extreme programming. He wrote in 90s, I think. Yeah, the other question maybe to the audience during Q&A. Have you used the Cloud Run jobs? I would be interested to hear your experience. About the cloud functions, by the way, I haven't made my mind, and I'll explain why. Because I used serverless in AWS before, in another company, and I remember we had some challenges of managing a lot of serverless, let's say, functions. If you know, there's the serverless framework, but we didn't like it. It didn't work in some cases for us very well. And then we managed all the serverless functions in Terraform, again, too verbose. In the end, I think in that company, everything was migrated to Kubernetes. So in the cloud functions, again, I'm a bit weary to kind of have a strategy of having many cloud functions now, because again, I think there will be an overlay of managing them. But maybe someone of you can share a good experience with cloud functions or other managing a lot of serverless functions. I would be happy to hear that and learn from you. Network security, interesting topic. So to VPN or not to VPN, that is a question. And actually, I had a very good discussion with Harles, who is the organizer of the conference. We managed to have a good talk about when I was, let's say, starting the infrastructure in the company, in the Google Cloud. And I was like, Harles, so we need VPN, right? And Harles was like a sage, or Yoda. He said, maybe you don't need VPN at all. And I was like, what do you mean? We don't need VPN. Everyone uses VPN. And but there was an interesting question, like, do we really need VPN? So raise your hands who use VPN. Okay, a lot of people. So what we opted for? We opted for embracing the zero trust access model, and we opted for using IAP. I believe we will have a more advanced talk about IAP and all of its capabilities later during the day, so hold on. I will not spoil the talk or talk too many details about that. But the idea is that IAP is identity-aware proxy, and you can configure your Google Cloud, let's say in our case Cloud Run, to use IAP. So it's pretty much authentication out of the box. And to manage the access authentication or authorization, you use the cloud IAM, identity and access management. And it turns out works well. And it turns out for now, we don't need VPN. I'm not saying we will not have the use case maybe in the future where we do need that, but so far we don't need that. And maybe that's also a call to new startups or companies. If you don't need VPN, don't use it. Like use identity-aware proxy or similar alternative solutions. It might be actually in the end more secure, and you will reduce the, your complexity of your infrastructure. You will reduce, your costs maybe a little bit, and you won't have unnecessary complexity. Another learning is set budget alerts, and trust me, as a CTO, you don't want to receive such messages from your CEO. From Prit Saloma, this was, by the way, I made a screenshot about it from my email box. It was a while ago, but he said, hey, our cloud costs are ramping up. Could you double check what's causing it? And then the next message was, this is quite high. What was the result in looking into the cloud costs? So what turned out to be is that we spin up a default instance in Postgres, and it turned out to be really beefy. So just keep it in mind. So first set budget alerts and check the default settings. So in the end, I fixed it, and Prit wrote to me nice, and we moved on. So, but yeah, we overpaid a couple of €1,000, like maybe €2,000. And that's a lot for a startup, actually, when you count every cent, So another learning, maybe from my whole, let's say, career experience working in Wise and Starship and now in Better Medicine is separate business concerns from infra in code, meaning code to an interface and protect your business logic from protect your business concerns, your core business logic from infrastructure, very specific infrastructure implementations that your business doesn't need to know about, or business logic. So for example, does your business logic really need to know that you use Postgres? Does this dependency have to be on the import inside the business logic code? It makes it hard to test, hard to mock, whatnot, and it makes it harder in the end to replace it in case you really need it, or to make your modules testable. So yeah, this diagram was taken from the book Patterns, Principles, and Practices of Domain-Driven Design by Scott Millett. I recommend this book. I was recommended to read this book back when I was starting in TransferWise from one very smart engineer, Urgo, who is now working as a VP of engineering in Clean Kitchen, I think. But yeah, I think following DDD principles generally is very sensible. Point your dependencies inward. Your domain layer, your business layer shouldn't depend on outer layers. You should inject them in runtime, let's say in your main, right? So if you have a Postgres, let's say, have a repository defined in your business layer. Let's say if you need to interact with whatever, we have this study, which stands for, let's say, this CT study, or it kind of represents, in our case, let's say, one computer tomography image, so to speak. We can define the repository layer in the service layer, and then we can operate based on that. Then we can create mocks, we can test, and business layer doesn't know anything about the fact that it's Postgres. Again, this is like a common sense, and probably everyone knows about it, but it's never, I find that it's never enough to repeat it, because when we look at our code bases, a lot of it eventually sprinkles down into the business logic, and then it bites us later on. So yeah, this is a good learning, maybe keep it in mind. Another thing I want to talk about is microservices versus monolith, right, discussion. And it goes like this, right, that many people read about microservices, maybe some read the books by Sam Newman, used in many companies, big companies. TransferWise uses microservices, Starship now uses microservices. Back in the day, by the way, when I started in Wise, Wise didn't use microservice. It was a monolith. But my idea is maybe don't start with microservice. Start with, if you even have separate modules when you start your business, like put them in a monolith. Modularize in the beginning, sure, as you need. And you can organize your code per bounded context, per your, let's say, module. But don't separate into microservice yet. And the main reason is you're still learning about your domain and about your business. And if you separate too fast, you will end up with a distributed BOM, B-BOM. Who knows what is B-BOM? It's big ball of mud. So this is what is distributed B-BOM. And pretty much what happens in distributed B-BOM, one example is you make a split of microservices incorrectly or not wisely. You haven't separated the interfaces well. Things are still talking to the same database, but these are microservices. Maybe you deploy in lockstep all the time. You have a distributed B-BOM. You don't reap too many benefits of microservices while having a lot of liabilities if you don't make a split correct. So that's why I like this graph. When you make these technical decisions, especially early on in the company, think about the modularity versus the number of deployment units. And in my opinion, you have to keep the number of deployment units when you start smaller, rather smaller, and only increase them when you're, let's say, load requirements or scalability requirements really require that. But if you have a modular monolith, it's always easy then split correctly to microservices. Because over time also it's easier to refactor in a modular monolith rather than it's not that easy to refactor or move things around when they're already in microservices. So when you start a new thing, especially when the domain is very new, start with the modular monolith and don't end up in this lower quadrant of distributed big ball of mud. So think about code organization, think about isolating dependencies when you do the modular monolith, and enforce the boundaries eventually with clear APIs. And you can do it all first in the modular monolith, and then if you do all these three things correctly, then the split will be very easy. Another thing what we do, playbooks. And I'll be honest, I took this practice from Starship. When I worked in Starship, a very talented engineer, I think he still works there, Martin Pichlak. Maybe people know them here, who worked in Skype as well. Martin Pichlak is pretty much the lead of SRE and maybe now of a bigger department. I don't know his title, but he introduced this very cool thing called playbooks, and it meant that every team writes a list of exactly like an instruction, like IKEA instruction. How would you assemble the furniture? Of what you do when your service goes down. So when shit hits the fan, what do you do? And any engineer in the company pretty much following that playbook should be able to resolve, let's say, 90% of issues. Like the most common incidents that happen. Let's say something is down, what do you do? Where is your Grafana? Where are you monitoring? Where do you check your logs? What's your service names? What services does your team own, and what should I check? And it helped a lot with the on-call, because then if someone was on call who was not part of that team, he was just able to look into the playbooks and resolve the issue. And playbooks included things like symptoms, like for example, what could go wrong, and the potential ways of solving the issue, kind of in a prioritized order with the most common use cases first. I mean, this is just a very generic output of things like, again, like you can even go as detailed as list containers and have a command. Of course, everyone knows how to list, or those who deal with Docker and others, like how to list the logs. But trust me, if you especially have many flags in the commands, it's very helpful to have it so you just copy paste. Because the last thing you want to do when you wake up at night, or when you're like, I remember in Starship, I had an incident when I was literally drilling the pull-up bar in my home, like into the concrete. I was drilling that, and then I receive on my pager that I have an incident, and I had to like solve the incident. That was quite fun. So in these moments, you really want to have these playbooks. So I recommend that, and we have the same strategy in Better Medicine. We have those playbooks, and they really help. Also, they help with onboarding. So if you have new engineers joining, they will first of all learn a lot about the system by reading your playbooks. And they will, in the end, they will also contribute to that. Because think about it. The new engineer comes with the mindset of like not knowing about anything. And the first time they go through the playbook, they will see that something is missing. And they will contribute to the playbook and make it even better. So the team culture. We do product engineering end to end. And I know maybe it might change in the later phases of the company. But from now, we do everything from speaking to radiologists to doing front-end, back-end DevOps. Of course, our product engineering team is small. It's 3 people, and this might change in the future. But we find that at this size, it works really well. Other bits, we do pair programming 50% of the time. We find it's very effective technique. We even experiment with mob programming. We do it once a week, Monday, early morning, 10 to 12. It's a very good way to warm up the team and to kind of kickstart the week and solve the real problem together. Especially, mob programming is really good for solving like hard problems together. That needs a little bit of tinkering and brainstorming. We do test-driven development as a default, but if you really despise TDD, full test coverage is still expected. Yeah, I have one team member, Veljo, who doesn't like TDD, and that's fine. I say, yeah, it's okay, but in the end, just have a full test coverage. And if you really don't like that, it's fine by you. Retrospectives. Yeah, we take retros, by the way, very seriously. In this way, we follow, I would say, like a true agile. Again, everyone talks about true agile nowadays and says that everyone else does agile incorrectly. But my point is maybe that we don't follow some silver bullet. Every week, we very carefully analyze how our week went, and we really generate action points how to improve the ways how we work as a team. And we do blameless postmortems. If you don't know about it, just Google what is blameless postmortems. It's how you take learnings from the incidents, because they will happen, and they do happen. And next steps for us, in terms of DevOps maybe and other things, we want to move to Grafana Prometheus, most likely, for improving monitoring. Currently, we just use cloud, let's say the logs. For error monitoring, we use Sentry. And for metrics, we have, let's say, log-based metrics. But I really like the stack of Grafana Prometheus, personally. We want to move all infra management to Terraform. Currently, we have very few services, so it was okay to manage it by hand, but we know it will get out of hands very quickly, so we want to move to Terraform. We want to improve our data management in Sandbox and other environments, especially we want to make sure that the CTs, or computer tomography images that we have in our Sandbox or the things that we test against are as realistic as possible, and we have enough of the, let's say, the data variety covered in Sandbox, and that's maybe other, I guess, problem that many others in other companies face. Yeah, optimizing things in Circle CI. We use Circle CI for our pipeline. And by the way, the talk on Google Cloud from Moon Cascade was very good. And after that, I realized, yeah, we really should improve our access management and clean up in Google Cloud. Thank you very much. Now Q&A. And yep, this is in case you want information.
Thank you. A very insightful talk. Do we have questions? Again, usual suspects.
Yeah, thanks very much for the talk. You mentioned that does your product really need to know about infrastructure, and then showed an example of PostgreSQL. It's not like infrastructure really, that's kind of a database technology, right? This is the first point. The second point is is it really a problem to have the integration testing between them? Because for example, in Bolt, we created some technology that allows to get up a container with a database or with another service, and you can run several comp tests against them. Also, there's a test containers technology that allows you to do pretty much the same. So basically, using any kind of a database is not a problem for integration testing, because you can rebuild the infrastructure on CI/CD pipeline or local machine. So. What do you think about that?
So, to keep the microphone, because I think I didn't realize the question was, so for let me just state some facts and then we will clarify the question maybe. So, we use Postgres as the backend for our medical image viewer, right? Like to serve the segmentations and other things. We use Postgres as well for integration tests. And your question was about the Postgres?
Is it really a problem that your code knows it's Postgres?
Oh, yeah, okay. I can answer that. Of course, it is. In a sense that, well, you could, how to say, there's a continuum of how you can argue about that or discuss that. If you have a very small code base, very, very small, of course, you can have everything, let's say, we can call it spaghetti code, but let's say there's no separation of the, concerns, and your whole code knows that this is Postgres, it knows about DB pool or other things. But it's important for your business logic over time to really, a lot of things don't need to know it's Postgres. And why it's important, it enables testing. It makes the testability of modules much more crisp, much better, and it's single responsibility principle. You try to decouple concerns of infrastructure and other things. In another example, let's say you can have what I mean by that, let's say you can have a logic or the use case where you know that at the end of the operation you need to send a message through Kafka, right? But let's say, but what if tomorrow you change Kafka to something else? So what you can do in the business logic, you can just have some messaging service interface which does that. And then it's much easier to test this module. And you don't have to mock the whole Kafka thing, but you just, you just write the mock implementation. But I think the long answer is, yes, I think it's important. It's important to separate these concerns, and it's good if you start early, because these kind of things accumulate over time, and then it's hard to separate them in the future.
Okay, got it. Thank you.
Do we have more questions? Okay.
Thank you, very insightful speech. I wanted to ask about this monolithic and microservice, vice versa. I personally have an opinion that doing things from the beginning right way is in the long run much more effective. And I don't know, I'm a DevOps and not the developer. I don't know very much about the code, but doing the infrastructure setup from startup the infrastructure as a code, it's much more painful at the beginning, but in long run, I feel it's much more, it pays out eventually.
Yeah, I can answer that, yes. Very good question, by the way. We wanted to start infrastructure as code from the very beginning. The problem is, for you to realize, when I joined the team, I asked, so, Preet, so what do we have already? Like, do we have any infrastructure? Do we have anything? He said, we have nothing. Figure everything out. And pretty much, for you to understand, in such a small startup, it was even before I hired Veljo and Thomas as engineers. I was the only person doing everything. And it meant talking to hospitals, building this BM gateway for anonymization, pseudonymization, for moving data. There were a lot of moving parts, and your time is so valuable. So it was a technical debt that I knew we would have to handle in the future. And you're right, it will kind of bite us a little bit in this future when we will do migration. That's why we realized this technical debt. We're conscious of that. And we know we want to move as soon as possible. But it was just the physical lack of resources to do it at that time. And I made the conscious decision to postpone it. But yes, there's this balance. When do you postpone things, when do you not? And in startups, you have to make a call. And I made such a call, but knowing that we will do the migration later.
Absolutely. Good answer.
I have a very specific technical question about Go. Do you prefer to keep your interfaces near the implementation or the usage itself? I ask because I had quite a problem when I tried to keep them near the usage itself, because I used FX. You probably know that library for dependency injection.
I know.
Yeah, and there you have to annotate the interfaces when you try to do that thingy.
Okay.
So that's why.
So one thing about Go is that currently we wire dependencies on our own, because actually, surprise, surprise, Java people, when they hear that people can wire their dependencies on their own, they probably freak out, because you use Spring for that, right, or something like in annotations. But yes, in Go, you wire dependencies yourself, and it might be fine. But to answer your question is, yes, I always I prefer to keep my interfaces with the usage. So, and it all depends on kind of your, let's say, dependency structure. So I'll give you an example. So for example, if your business logic is the one who cares how the interface should look like or what kind of operations with the data storage it should do, it's the one to dictate that, then it should define the interface. And then usually the implementations they can be even in outside packages. I'll give you actually an example. It was in this, this is from Google, yeah. So you can see that actually, you see this integration thing? So their implementations of this different KMS are in completely different package from the interface. So I think their interface is defined in like the core and stuff. Like this one is completely in different package. It's kind of in the main flow or in the core flow of the thing. But this is, the implementations are in completely different package. So I would rather prefer that. And we kind of have the same. For the repositories, we have the repositories are defined in the service layer, but the Postgres implementations are in completely different package. And then we wire them in main. We just say, whatever, new study repository, which is Postgres implemented. And we inject it. Okay,
thank you. Let's have a big round of applause.
Thank you. Thank you.